is a module. So modularity is a single attribute of software that allows a program to be intellectually manageable. So modularity is nothing but is a single attribute. That means whatever the modules you divided in that each module, you're working on the each module is called as a modularity. So attribute of a software that allows a program to be intellectually manageable. So managing of the whole software means it's a hard. So managing of some module, one module means it will be easy. So that is intellectually your manageable. Okay. And next. So this is some modularity, some graph. Okay. Modularity and software cost. So here we have given some number of modules. So this is the cost of effort. That means dividing the software into some modules. That means after division also, so how much cost you can pay given on the each module. How much cost you can affordable to each module in order to complete the software. Okay, so that is a number of modules. That's why here number of modules and here is the cost of effort. Okay, so here, so if the modules, number of modules is 2. Okay, maximum length we have taken the 2. Okay, so if you take this, so whatever the parabola, some parabolic arc you got, if you consider as a region of minimum cost. So by dividing the software into some modules, then the way of the cost implementation is also very low. So for that, it is showing the graph. Okay. So next one is the information hiding. So we have seen modularity, aspects, functional independence and refinement. So information hiding. So the principles of information hiding suggest the modules can be characterized by design decisions that hides from all others. So what is an abstraction? What we said in abstraction, the same thing is here. Okay. So characterized by design decisions that hides from all others. So whatever the things you want to show only the some output. You don't want to show the way of how you functionalized, the way of how you wrote the program. So that is the information hiding. So that is the abstraction. Okay. So in other words, modules should be specified and designed so that information contained within the module is inaccessible to other modules that have no need for such information. So from one module to another module, you don't want to reveal the program, what you have written. So for that information hiding, you will like that means if you have know about the public-private accesses. So public-private access specifiers. In programming languages, we use the public-private access specifiers and protected. And third one is a protected. I think you people know about this. Okay, if you don't know, just at that time I will tell. So you have some access specifiers in the language, in a programming language. Public, private, protected. So if it is a private access specifier, then it will not reveal the class variables to others. Okay, like that. So public means anyone can see. So protected means only particular thing what you are protecting, so that will not reveal outside. Outside means to other module. Okay. And next, the use of information hiding as a design criterion for modular systems provides the greatest benefits when modifications are required during testing and later software maintenance. So why we are making the information hiding in modules? So because in modules, if you make the information hiding process, so then it will be very easy for you after going for the testing. So before during testing, if you have any problems, or later software maintenance, if you have any problems, so they can be easily resolved. For example, if you write some C program, C programming is only one class will be having, so one main function will be have. So whatever the functions you have to maintain in the same one class. But in Java, you can represent so many of the classes. Okay. If you have represented so many of the classes, so which class variable has got the error? You can't able to know. Okay, so if you make these information hiding from one class to another class, so that means one module to another module, then it will be easy for the developers. So where the problem is occurred during the testing hours or after the maintenance of the software. Because most of the data and procedural data are hidden from other parts of the software, inadvertent errors introduced during the modifications. Okay, so because of this hiding, so it will be very useful for the things. And next, functional independence. So the concept of functional independence is a direct outgrowth of the separation of concerns modularity and the concepts of abstraction and information hiding. So this functional independence is mainly, so it is a part of the separation of concerns. So, and it is also the concept of abstraction and information hiding. So what is the functional independence? So what is it? So functional independence is achieved by developing modules with a single-minded function and an aversion to excessive interaction with other modules. So functional independence. In the name itself, it is having the function independent. That means, so how we can achieve this functional independence? So this functional independence is achieved by developing the modules. So whatever the modules you are developing with single-minded. That means only one person has to do that one module. So multiple persons will involve in the module. One module means it will get some diversions. Okay. And next, independence is necessary using two qualitative criteria. So what is the functional independence? So what is independence? So independence is individual. So here independence is necessary using two qualitative criteria. At what purpose we are using the independences? One is cohesion and second one is the coupling. So what is cohesion? What is coupling? How these are coming under the qualitative criteria in independence? So let us see that. So cohesion is an indication of the relative functional strength of your module. Okay, what is a cohesion? Cohesion is an indication of the relative functional strength of a module. So whatever in module, okay, in the module, which function plays an important role? So your people will use some class. Okay, so for example, class add. So this is one class. In class, you will write some logic with some function. Add. Add is a one function. Okay. So this add function plays an important role because the whole logic will be placed in this add function. Similarly, cohesion is nothing but, so what it is an indication of relative functional strength of your module. So how that module will work? So what is the main that module function? So without that module, how the software will be? So by introducing that module into the software, how the software will react. Okay. So that is the cohesion. So what is the coupling? So coupling is also an indication of the relative interdependence among the modules. So you divided some software or some system into some 3 or 4 or maximum 2 or 3 modules. Okay, so individual module means cohesion. Individual module related strength, functional strength. What is coupling is, so when you are making those 2 or 3 modules in a single system, a single software, then how they are related interdependence among the modules. How they are internally independent with each other. How they are related interdependence. Okay. So front end, back end. So how you are connecting these two. So that is a coupling. Okay. And next one is refinement. So what is a refinement? So stepwise refinement is a top-down design strategy originally proposed by Nicholas Worth. Okay, he is one of the contributor for the software engineering. So refinement is actually a process of elaboration. Okay, refining means again and again we are going to doing some test on that. Okay, so for example, oil is refined oil. Why we are saying the refined oil? We are filtering all the mud. We are filtering all the bacteria, whatever it is there in the particular thing. Like that, in the software also we have to make some refinement. So what is the meaning of refinement? Is actually a process of elaboration. You begin with a statement of function that is defined at a high level of abstraction. So first one is the abstraction and refinement. Let us see what is the abstraction and refinement. So this refinement is at a high level. So what is that? So abstraction and refinement are complementary concepts. Complementary means against each other. Abstraction enables you to specify procedure and data internally but suppress the need for the outsiders. So I said, what is the abstraction? Abstraction is nothing but hiding the details. So it has the data internally, but that is not revealed to the outsiders. So that is the thing here. So to have knowledge of low level details. Okay. So refinement helps to reveal low level details as a design progresses. So abstraction is hide the data from high level and it will not reveal whatever the functions or variables or attributes, whatever you described in the class will not reveal to the next low level classes. That is the abstraction. Whereas refinement is reveal the low level details in design process. As a design process. So in low levels, whatever the things you are defined, those will be revealed. Okay. And next one is the aspects. So what is the aspects? So an aspect is a representation of a cross-cutting concern. So a cross-cutting concern is some characteristics of the system that applies across many different requirements. So aspects is nothing but stakeholder will give us some different requirements. So in what way the requirement will be used about all those requirements. So this first requirement, whatever I give the stakeholder, in what aspect, that means in what way this requirement will help the software to develop in the product development. Okay. So an aspect is a representation of the cross-cutting concern. So which requirements we have to cross-cutting, that means we have to remove. So we have not considered. Okay. So that is the aspects. And next one is the refactoring. So what is a refactoring? So an important design activity suggested for many agile methods. So have you remember the agile methods? Agile methods. We have the different agile process methods. Industrial programming, extreme industrial programming, programming, industrial extreme programming, DSD, FDD. Okay, so we have so many of the Scrum, like that we have so many of the agile methods. Okay, so this refactoring is mainly suggested for the agile methods. So refactoring is a reorganization technique. So refactoring is nothing but reorganization of the. So refactoring is nothing but is a reorganization technique. So what it does, it simplifies the design or code. So it simplifies the design or code of a component without changing its function or behavior. Okay. So refactoring, for example, mobile phones. So the mobile phone will not change anything. We will implement some more things in that. So if you have seen GSM mobiles, they has some one point is refactor. Okay, factory reset. Factory reset, like that one option will be available in the GSM phones. Of course, in Android also you will have some restore, whatever we call as a restore. So what it will do? So restoring means it will come to all the default values. So like that, refactoring. So refactoring is nothing but whatever the design you did in order to simplify that. So refactoring concept is came into existence. Okay. So in this refactoring, you can't change its functional behavior. Okay, how it is working, how it is behaving. So it will not change. Only thing is, we can add some more functions, okay, into it. So Flower is one of the contributor. So Flower defines the refactoring. So what he defines? He defines the refactoring in the following manner. So what is that refactoring? So the definition of the refactoring is a process of changing a software system in such a way that it does not alter the behavior, external behavior of the code, yet improves its internal structure. For example, mobile phones, Android mobile phones. So you are getting the different models. So what is the internal function? Internal function is the same, but the way it looks, okay, the way it appears is changing. So if you have seen some Samsung different models or Redmi different models, what is the change in that? Only the way it looks, or some battery changes, only the screen designing, that will be changed. But internal function of the phone is the same. All Android phones of internal function is the same, but only the thing is outside looking. The same thing. So refactoring is a process of changing the software system in such a way that it doesn't alter the external behavior of the code, yet improves its internal structure. Okay. And next, object-oriented design concepts. So what are the object-oriented design concepts? So this is also one. So up to now we have seen the separation of concepts. In separation of concepts we have modularity, aspects, functional independence, and next one is the functional independence and refinement. Okay. So that is the separation of concepts. So the separation of concern is a subtopic of the design concepts, like that. So object-oriented design concept is also subtopic of the design concepts. So what is this object-oriented design concepts? The object-oriented design concepts, we can say as O. So we have the shortcut OOP. OOPS. Some scores you people will heard the word OOPS, object-oriented programming language. So okay, it will not come, yes, only object-oriented programming. Like that. So object-oriented, OO, paradigm is nothing but some program, is widely used in modern software engineering. Okay, so in modern software engineering, this object-oriented came into existence. So what is that? So what OO, object-oriented, OO means object-oriented. Design concepts such as classes, objects, inheritance, messages, and polymorphism, among others. So we are saying object-oriented programming language. So what is the not programming language? Let's go for the software engineering. Object-oriented paradigm. So what is that object-oriented? What is object? What is orientation? That means the thing, whatever the class or whatever the things you are defined, so that all rotate through the object. Basing upon the object, the overall process will be done. So that is the object oriented. So what is the object? So what is an object? Object is nothing but it is a real world entity. Real world. WORLD. World entity. That means, see, marker, this is a object, okay. Remote, so this is an object. And there is a smart board, this is an object. Like that. So whatever the things you are saying, those are called as an object. So like that, basing upon that object, the whole program is going on. The whole functioning of the system is going on. Then it is called as an object oriented. So what are the concepts in that? So what are the concepts will be available in the object oriented? So the first one is the classes. So we have seen classes. Classes is nothing but it is a set of attributes and functions of an object, behavior of an object. So that is the classes. Next, objects. Classes and objects. Next, inheritance. So that is the one concept, inheritance. Messages and polymorphism. Okay, so these are the concepts comes under the OOPS, object-oriented programming. Not programming, object-oriented. Okay, so this is a. So first we will go for the design classes. So first we will go for the design classes. So the requirements model define a set of analysis classes. Okay. We have seen the requirement models. So in the scenario based or in the behavioral based, we have the class based models. In the requirement models, we have seen the class based models. Okay, each describes some element of the problem domain, focusing on aspects of the problem that are user visible. Okay, so what this class based on? So why we are going for the class? So what it defines? So each describes some element of the problem domain. So in particular domain, what is the problem? And it also focuses on aspects of the problem. So how we can solve that problem in different aspects, in different views. A set of design classes that define analysis classes by providing design detail that will enable classes to be implemented and implement a software infrastructure that supports the business solution. So by using this classes model, so we have to refine some analysis of the classes in the requirement model. So what it provides? It provides some design details. So what are the design details? So by using the class diagrams, it will provide some design detail. Okay, first it has to go like this. So there is a one-to-many relationship. So between these objects, they have some one-to-one relationship. Like that, it is give us some structure. Okay, and next. So 5 different types of design classes, each representing a different layer of the design architecture can be developed. Okay, so there are different types of classes. There are five different types of classes, each representing a different layer of architecture. So we define the classes. Okay, there are 5 types of the classes. Each class will give the one layer to the architecture. So and can be developed. So what are those classes? And the first class is user interface classes. Okay, so what is this user interface classes? So this user interface classes define all abstractions that are necessary for human-computer interaction. So this user interface classes will give all the necessary for the human-computer interaction. Or what is the human-computer interaction? So human means ourselves. Computer, that means system. Interaction, how the interaction will going between these two, human and computer. That means how the system will be faced by the human and how the human will face the system. So for example, if people are on the laptop, so after on in the laptop, if you have some problem, if you encounter some problem, so what you people do? Okay, so if after on in the system, if you are making want to open some document, but it is not opening, so then what you then human how it react for that? So how the design process will affect the user. So what are the colors we have to use in the screen design? Why colors designing is also plays an important role. So that is comes under the human-computer interaction. Okay. The design classes for interface may be visual representation of the elements of the metaphor. So in this user interface classes, what it is, it represents the visual representation. Interface is nothing but how to face the system. So in order to face the system, it has to be look some good. If it has some good screen design, then we can able to face. For example, Windows, if people are known about the Windows, if you go for the Unix or Linux operating system, people cannot operate with it. Because the design of the system will be different from the Windows. Okay. And next, and second one is the system classes. So first one is the user interface classes and second one is the system classes. So what is the system classes? System classes implement software management and control functions that enable the system operate and communicate with its computing environment and with the outside world. So what is the system classes is? These system classes implement software management and control the functions. So whatever the program you have written, whatever the things, functions you have written, that management will be done by this system classes. Okay. Next, business domain classes. So what are the business domain classes? So these classes are often refinement of the analysis. So we have seen the what is a refinement. In refinement we have seen the some analysis of the requirement models. So the same thing will be applied over the business domain. Okay. The classes identify the attributes and service of the management functions that are required to implement some element of the business domain. So in this, it will identify the attributes and functions. So what is the attributes for this? That means the variables what we have to declare. So what are the functions we have to write for those variables that are required to implement some elements of the business domain. Okay. And next, fourth one is process classes. So what is the process classes? So process classes implement lower level business abstractions. So lower level business abstractions required to fully manage the business domain classes. So in order to maintain these domain classes, these process classes came into existence. And next, persistent classes. So what are the persistent classes? So persistent classes represent data stores. Example, database that will persist beyond the execution of the software. So these persist classes, we use these classes in the design process for the representation of the data stores. So how the database can be represented in architectural model in design process. We use the persistent classes. Okay, so these are the different 5 types of the classes. So the first one is the design classes. First one is the user interface classes. Second one is the system classes. Thirdly, business domain classes. Fourth one, process classes. And fifth one is the persistent classes. So these are the different classes in order to represent the system, in order to represent the design process. In the design process, for persistent classes, it will represent for the execution of the database, that means data storing of the data. Okay, these are the different types of the classes we use in the object-oriented design concepts. Okay, and next. So by this I conclude the session. So we have seen the concepts of architecture, and also we have seen different refinement, separation of concerns, and we have seen about the object-oriented paradigm concept. So by this, today's session is completed.